All right, Cliff Notes number 23 is what it is for our new Cliff Note book. Mean value theorem and Rolle's theorem. Okay, the background information we need right here. All right, so what has to be true of the function we're working with? That it has to be continuous and differentiable. Okay, so the derivative at some particular x value has got to equal, needs to equal the slope through the endpoints. So here's our formula, the conditions that have to be met. Now notice that Rolle's theorem is a special case of the MVT. And all it's saying is that your endpoints land at the same y value. And if you think about it, if you have a graph whose endpoints land at the same y value here, that the slope through those endpoints is going to be 0. So that this graph, whatever it's doing, has to have at least one horizontal tangent somewhere in between A and B. And clearly we can see that we do have at least one horizontal tangent between A and B when the y values are the same at the endpoints. So let's look at some examples of the mean value theorem and Rolle's theorem. All right, so for example, number 1, let f be a function given by this polynomial, this cubic equation. Remember, a polynomial implies that this graph can be drawn without lifting our pencil. There's no sharp turn. So a polynomial function, in that word itself, polynomial, implies differentiability, which also implies continuity. All right, so we've got a third-degree equation. Find the c between these values, these a and b values. Find the x that, or c, between 1 and 3 that satisfies the conclusion of the mean value theorem. Okay, just saying use the formula itself. Okay. All right. All right, so in my attempt to memorize the formula, I always write it down. The derivative is equal to the slope through the endpoints. So we have some side work to do over here. Let's go ahead and first find the derivative of the given function. 3x squared minus 7. They just choose to use c for this particular x value. So if you wanted to, you could change it to a c. Everywhere you see x, replace it with c. It's just their choice. Okay, what else do I need? I need the function evaluated, not the derivative. Notice there's no prime notation. I need the function evaluated at b and the function evaluated at a. So what's f of 1? Go to the original function, plug in 1. Everywhere you see 1, or everywhere you see x, sorry, you get, you plug in a 1, you get 0. And what's the function evaluated at 3? Plug in 3 everywhere you see x, and I did that computation and I got 12. Okay, so let's come back over here and put in all the necessary information. So the derivative evaluated at c is represented by the expression 3c squared minus 7 equals, okay, we've got two y values to subtract over the difference of the two x values. So 12 minus 0 over 3 minus 1. All right, 12 over 2 is 6. Okay, now algebraically, how do we solve this? Well, let's add a 7, divide by 3, and extract the roots. All right, so that means we're going to have a positive negative square root of 13/3. Okay, one of these is extraneous or extra because remember our target values are 1 to 3 and the negative number doesn't fit in between x is 1 and x is 3. So the only x value at which my slope of the graph is going to match the slope through the endpoints would be at this x value right here. All right, before we leave this problem real quickly, I want to get you a visual. Okay, what did we just find? Okay, we found an x value where the slope of the graph is the same as the slope of the endpoints. Think about graphing this cubic. Okay, and if you wanted to put it into your calculator and graph it, it's going to look something like this. Okay, so that's the function. Okay, let's pick out the interval where x is 1. Well, that actually happens to be at 1, 0, as you can see through the ordered pair 1, 0. Okay, look at 312. 312 is going to be up here. Okay, if you were to draw in the secant line through these 2 points, that's the average rate of change. on that interval. So what we're looking at is just this part of the graph right here between these two x's. Okay, and so where is the slope of the graph the same? Well, it's saying that at this x value, the slope of the graph at that one point is the same as the slope to the endpoints. And this is like 2.08. If you change that to a decimal, it's 2.08. It's going to be about right, probably about right here. And if you think about the slope of the graph, notice how, okay, these two lines, the secant line and the tangent line, the tangent to the graph at that x value, they're parallel. So that's what the mean value theorem does for us. All right, let's look at example 2. All right, so f is a function that is differentiable. Remember, that implies continuity. It also tells us that the second derivative is positive for all x. So even though we're not going to use this information, this is really telling us that the graph of the function is concave up everywhere. For this particular question, we don't need this information, but it's also important to continue, translating, because you never know what question might involve this information. All right, we're going to use the chart to find a positive number r having the property that there must exist a value c, where c is between 0 and 0.5, and r is equal to the second derivative evaluated at c. Okay, so I think in yours it says find the average rate of change of r. Find the average rate of change of r, but the way this problem was originally presented, it was in this format right here. Using the chart below, find a positive number r. Okay, well, because yours says average rate of change, that's pretty simple here. Then what we can do is we can use these values, which we're going to consider a and b, and we're going to do a delta y over delta x between these two x values. And the trick here is what y values do we use? Do we use the f of x values, or do we use the f prime of x values? Well, because I'm needing to find the second derivative, the average rate of change of the first derivative are the values that we're going to use. So it's just a modified version of the mean value theorem. So the average rate of change between the two y values on the derivative graph. So this is what the formula looks like. All right, so let's find a slope, which they're calling an r value. Okay, so f prime of b, well, b is 0.5. Here's 0.5. F prime is 3. Minus f prime of 0. Here's 0. So the f prime value is 0. And then let's subtract the 0.5 and the 0. So 0.5 minus 0 is 0.5. So 3 over a half, and 3 divided by a half is just going to be 6. All right, give a reason for your answer. They're just wanting you to use some words. So what we're going to do is we're just going to throw in the mean value theorem here. All right, we want to state the condition that allows us to use the MVT, and that's just differentiability. Since f is differentiable, the MVT applies. And I probably would write this whole expression down again, but since my work is there, I think we're covered. So I'm just going to go straight to what they wanted me to find. All right, moving on to the next example. All right, to determine if Rolle's theorem applies, we have to have a differentiable function. Well, this polynomial function is differentiable. The other condition is the y values have to be the same at the endpoints. So this is a, this is b. Let's find f of -2. And everywhere I see x, replace it with -2. And to save time, that's going to equal 8. Plug in b. Everywhere I see x, I'm going to plug in 2. And when I do, I also get 8. Which means when I do a delta y over delta x, I'm going to get a 0 slope. All right, so the next thing is let's find the derivative. Everywhere I see X, let's replace it with C. Again, this is a kind of a needless step. Okay, and then over here, because the theorem applies, I'm going to go ahead and write out the mean value theorem. Okay, below it, let's place in the necessary information. Okay, B and A, again, this is A, this is B. So 2 minus -2, subtract the Y values on top. Okay, we know that's going to be equal to 0. 0 over 4, which is just 0. Did I have to go through all this? No, I could just say it's equal to 0. How do I solve this? Well, let's factor out the common factor of 4C. Okay, do yourself a favor, always check by distributing back in to see if you get the previous line. Okay, continuing to solve, either 4C is 0, which means C is 0, okay, or C minus 1 is 0, or solving is C equals 1. Let's double check to see if both of these fall within the interval, not including the endpoints. Okay, yeah, 0 and 1 both fall in there, so these are both the X values at which we have a horizontal tangent. Okay, and you might want to check that by a visual of it by graphing that in Y1, okay, and seeing that it's going to have 2 horizontal tangents. All right, let's go to example 4. All right, I see some points that are given here, some ordered pairs, and the best thing you want to do for yourself, a good strategy here, is to plot those points, keeping in mind that the function is differentiable, so avoid any sharp turns, vertical tangents. The graph must be continuous. Okay, so I'm going to draw a quick graph. All right, this is one such graph. Okay, the graph that contains these 3 given points up here. All right, which of the following must be true? Does the function have to have at least 2 zeros? Yes. Okay, there's no way I can go from this point to this point to this point without passing through the x-axis twice. Okay, so this is really the IVT. If my lowest y value is -5 and my highest y value is 5 and I have to go up and back down, then yes, I have to have 2 zeros. So that has to be true. Does the graph have to have at least 1 horizontal tangent line? Well, is the function differentiable? Yes. Okay, which implies it's continuous. Okay, look at the slope through the 2 endpoints of the graph, at least right here through these 2 points. The slope is 0, so somewhere between 2 and 9, I have to have at least 1 horizontal tangent because of the Rolle's theorem. All right, does it have to be true that somewhere between 2 and 5 that my y value is 3? Well, let's only focus on those 2 points then, this point and this point. Okay, if I go from -5 up to +5, I have to pass through a y value of 3 somewhere in here. So that has to be true as well. Okay, so if this was a multiple choice format, then the choice I would choose would be the one that includes 1, 2, and 3. So they're all true. So this page reviewed mean value theorem, Rolle's theorem, but it also included some IVT review too.